Hello, welcome to the seminar on using SAS macros. I'm Michael and I'm joined by...
I'm Shell.
So I hope that you're going to enjoy this seminar on SAS macros. What we're going to do, this isn't going to be a comprehensive seminar on SAS macros, but in the next about hour and 15 minutes or so, we're going to introduce you to the use of SAS macros. So first off, let's just dive right in. That from our main webpage here, and that's www.ats.ucla.edu/stat, we'll go to our classes and seminars page, and then within the section here on SAS, we have the seminar on Introduction to the SAS Macro Language. So we'll click on this, and then here's the webpage that we're going to be working off of. Also, in addition to this web page, we have a program which has all the commands. So if you click on this link here, here's the entire SAS program that we're going to be working off of. So you can copy and paste this program into your own SAS session, and you can try out all the commands, and we really encourage you to do that to, practice this for yourself. So I'm going to click back here, and then now we're going to work off of the web page. So first off, let's quickly talk about the things we're going to do here. That we're going to introduce the basics about macro variables. We'll talk about some macro functions. We'll talk about symput and symget for getting information to macros and from macros into a data step. We'll talk about how you can create macros using ProcSQL. We'll talk about a couple of macro programs, one which creates a list of file names for a data step, and then a final little macro program for repeating a procedure multiple times. So that's our agenda here. So let's dive into the use of macro variables. So first off, we have this little data set that we're going to be using. We're going to call this little data set HSB2. It doesn't really matter what's in it. So from this data set, once we have this in, say that we wanted to run a proc means, and we want to run that proc means on the variables right, math, female, and social studies. And then say again we wanted to do a proc reg, again incorporating the variables right, math, female, social studies. Well, one of the things that we notice here is that these variables are the same across these procedures, and maybe you might have the same thing going on over and over and over again. So there's a shortcut that you could do. You could define a macro variable and then use that macro variable in the procedures. In fact, let's go over to SAS. So I'm going to bring SAS up right here. And here we've got that data step. So what I'm going to do is I'm going to read the data in. So I'm going to mark this data. And I'm going to run this. And we see in the log, okay, we've got the data. It read in successfully. So now... here we've got the example of what we might want to do just using regular SAS language. So I'm going to click on this and I'm going to run this. And we see that those two statements ran fine as you expected. But that's the sort of first step that you want to do before you try converting it over into using SAS macros. So now what I'm going to do is I'm going to use this %let statement to create a macro variable called indvars for independent variables. And this macro variable contains right, math, female, and social studies. So now, when I do this proc means here, rather than spelling out all of those variables, I can put in ampersand indvars. Notice that the ampersand here, that's the key to SAS saying, hey, this is a macro variable. Don't just put in whatever this word is. Substitute in how I've defined this macro variable previously. So if I run this, then I run this, it will substitute that in. In fact, let's try it. So I'm going to mark just this amount, and I'm going to run this. And I look at the log file here, and it says proc means yada yada var ampersand indvars, and then here it runs it, but it didn't really just use ampersand indvars, it did the substitution. So when I look at the output, I see, it did the proc means on right, math, female, and social studies. So that's pretty handy. And then I can use it again. Here I can use it in this proc reg. Again, I'm using this ampersand indvars, and I run this. And now with my proc reg, it's used those same variables. I could do this again with another proc reg, with another proc means, and so forth. and then save the typing. And then if later I decided to add another independent variable here, I could rerun all of these statements by only having to type it once rather than having to type it multiple times. So that's a pretty simple use of Sass macros. Now if you wanted to see what was inside of a macro, you can use this ampersand put statement. So here we're saying ampersand put, my first macro variable int vars is, and then I'm saying to Sass, please show me the value of that macro variable. So if I mark this, and if I run it, it doesn't look like anything happened. But if I look at the log file, oh, here, I see that here's the statement that I executed, and then here is what Sass did. It showed this in the log file. So when I use %put, it's saying show this in the log file, and if I mention any macro variables with an ampersand, please do the substitution. So that's pretty easy. So if I wanted to see all of the automatic variables that Sass creates, and Sass creates a whole lot of them, I could use this %put underscore automatic underscore, and then if I run this, oh my goodness, it gives us a whole lot of macro variables here. So if I scroll up, these are all macro variables that Sass creates automatically. Like here is a macro variable called sysdate, and today is indeed March 4th, 2004. It has sysdate 9 if I wanted the year to be expressed as full 4 digits. It's telling me that today is Friday, and it has all sorts of other macro variables here that it has automatically created, and I could use those if I wanted. And here we've got an example of us doing that. Here we've got a title statement, and we say today's date is ampersand sysdate 9, and today is ampersand sysday. So Sass will substitute in the date here and the day of week here because we've seen up above that those variables already exist. And then I can do proc means, and then I can use my own macro variable here. I've got my own macro variable int vars, and notice I've got a capital S here. This is showing that these aren't case sensitive, that I could spell this with upper, lowercase, however I prefer. So if I mark this and I run it, so now here I see in the output today's date is, here's the date, and here's Friday, so that got into the title statement, and the proc means used the variables that I specified. That's pretty good stuff. So previously, notice that this was in double quotes. What if I run the same thing but put the title statement in single quotes? So I'm going to try running this. Oh dear, the date is ampersand sysdate 9 and today is ampersand sysday. Oh, when I put this in single quotes, that signified to Sass that I wanted to treat this ampersand just as an ampersand. So not to indicate that it should be a macro variable that should be substituted for, that I should just treat it as a regular ampersand. And this is what you would do if you wanted to have a title where you wanted to say like this ampersand that, and you didn't want Sass to try to interpret that ampersand as a macro. So, and this also, if you ever use a single quote and you go, why didn't my macro get expanded? Well, that's why it did that. Now, what I'm going to do here is I'm going to use this %put, and I'm going to use underscore user underscore. Also, I'm going to run this title statement to erase any title that we've had previously. And when I run this, and I go to the log window, here it says, we've got this variable int vars, and this is what it has. And there's only one variable here that's been declared, and that's the variable that we declared. So underscore user underscore is basically a way of showing you all the macro variables that you've declared, as opposed to underscore automatic underscore, which shows all the macros that Sass declared. So that's some good stuff. Now, this next section here, we're going to be looking at macro functions. Sass has a lot of macro functions that help ease your processing of macros, and we should stop and think here a little bit about what macros contain. Macros contain string variables. Even when you put a number inside of a macro, SAS still treats it as a string. So if you assign the value of 123 to a macro, it's not thinking of it as 123. It's thinking of it as 1, 2, 3 as a string value. So most of the functions that we're going to see here are related to either doing string manipulations on macros or trying to coerce SAS into doing mathematical operations on those string values. So to dive in here, let's first remind ourselves what's contained in that macro variable indvars. So I just do the percent put, and we see, oh, okay, right, it's got right, math, female, social studies. What if I use this percent upcase function? As you might imagine, you probably are already guessing, what that's going to do is it's going to convert it into uppercase. So I'm making this new macro variable, new ind, equal to the uppercase version of indvars, and then I'm going to use percent put to show us what's in that. So I'm going to run that, and okay, here we go. Here we see that now we get right, math, female, social studies, but it's all in uppercase.
Notice that those macro functions, they all start with percent sign.
Oh, that's a very good point. So this differentiates these macro functions from your ordinary kind of data step functions. In fact, if I haven't emphasized it enough, notice that basically all of the macro language elements start with a percent. So that's the key to SAS. This is a bit of macro language.
And SAS is then going to do the translation process.
Exactly. So now let's move on to our next function here, and that's this scan function. This is a little bit less intuitive. Let's try running this, and then we can infer what it's doing. So I'm going to mark this, and I'm going to run it. I'm going to scroll up just a little bit, and we can see that when we did scan indvars passing in 2, it gave us math. Math. Oh, that's the second word in this string. So what scan is doing is saying, given this string, give me this word out of the string. Out of right, math, female, social studies, give me the second word. The second word is math. Okay, that's some pretty useful stuff. We'll see how much more useful this is a little bit later. So these are kind of little building blocks that we're going over right now without really going into how you would use these. This next function is substr, or substring, and this is for getting substrings out of macros. Here we're going to get the substring out of indvars starting at position 5 for a length of 3. I'm going to run this, and what we're going to see here is that we get E and M. Okay, if I scroll up here, we can see that, where is it? Right here. So 1, 2, 3, 4, 5. There's the 5th position in indvars. Now that I'm at the 5th position, now let's take 3. 1, 2, 3. So that's how I got E and M using this substring function. Okay, let's have a look at some more stuff here. Here I've got a variable k, and k has a value of 1. Now I'm going to say let tote equal ampersand k plus 1. So ampersand k is going to get substituted. What value will it have? It'll have 1. So this will be 1 plus 1. So let's run this and see what SAS does. So I run this, and when I put ampersand tote, it's 1 plus 1. Oh, shoot. What if I wanted it to be 2? What if I wanted SAS to evaluate that? Because right now, all SAS is doing is it's treating this as a string. Here's a 1, here's a plus sign, here's a 1, and then it's just showing that to us. But if we see in this next example here, and we use the percent eval, short for evaluate, what we're saying to SAS is, evaluate this and give me the arithmetic result of it. So let's mark this, and let's run this. And when we say evaluate 1 plus 1 and then put it back, it says, 2. So now we can see how we can actually ask SAS to do mathematical evaluation of macros. Here's another example. Now I'm going to ask SAS instead to add 1.234. Let's see what happens when we try this. Oops, we got a problem. SAS is complaining that it saw something kind of unexpected in the percent eval function. Well, the reason that it's complaining is that percent eval is designed to work only on integer values. 1.234, last time I checked, is not an integer value. So instead, we need to use this function, sysevalf, and I believe that that f would be for floating point, as in please do floating point operations on this. And you might ask yourself, well, why do we have this separate function? This function, because it's only working with integers, can work very, very fast. I should just point to this part, just the eval function. So that executes very quickly. The sysevalf, it has to do a lot more work, so it might run more slowly. You could just decide, I'm always going to use sysevalf. However, if you've got a macro that is very intense, it won't run nearly as fast as though you chose eval when you could have. So let's try running just this part. And now we see when we use sysevalf, 1 plus 1.234 is 2.234. Okay, good. So that concludes our section on functions.
Just out of curiosity, why do you put percent put at the end of...
Oh, that's a very good point. I've been putting in these extra percent puts here. And the reason that I did that was to put in a little blank line here, so between our examples they wouldn't all run together with each other.
I see. How smart.
So percent put is if you just go percent put semicolon, it's just saying, hey, put out a blank line to give me some extra white space here in between the examples. So now we're going to look at symput and symget. These are a little bit tricky. So first we're going to start with symput.
By the way, what do they do?
So symput is used for taking the value, now help me out here.
That's right. Taking the value from a data step, put it into a macro variable.
Right. So this is a good point to have a little pause here. We've been talking about macro variables, and if you've been using SAS, you're familiar with variables. Like in your data set, you've got reading, writing, math. How are these different? So in your data step, you have a data file that has reading, writing, math, and so forth. And in our little example, we've got like 20 or 30 observations. And then you've got these macro variables that live in another world, and they're just a single value, which have nothing to do with data step variables at all. However, you might want to take a value from a data step variable and push it into a macro variable. And that's what symput is for, to put the value of the macro variable put the value from the data step variable into the macro variable. See how easy it is to get confused here?
You can think this way because those are the data step functions. So you live in a data step.
Right.
So you put your data value to a macro variable. So when you symget, you get variable from get the value from macro variable to your data step.
Okay, that'll help us out.
Maybe we want to redo this part?
No. We're going to keep going. So here we've got proc means, and in this proc means, we're going to output a data set. So this proc means is counting up how many observations, or it's doing it just for the observations where right is 55 or more, and then it's outputting this to a data set right here And we're just going to make a variable n, which is the count of the number of observations that satisfy this criteria. We're just simply counting up how many observations have writing scores greater than or equal to 55, and then we're going to print this. So let's just do this much right now. And now we can see, here's this data set N55, or W55, and it has one observation, and we've got a variable n that has a value of 9. What if we then want to take that and then transfer that into a macro variable? So that is where we're going to use the simput function. And the way that we're going to do this is we're going to do this just using a data null step. We don't care about really creating a data file here. We're going to bring in the W55, which we see here's what W55 looks like up here. And then we're going to say call simput, and we're going to put the value of n, which currently is 9, and we're going to stuff that into a macro variable called N55. And notice that we put that in single quotation marks, and that's important, that's required. So if we run this, and we look at the log file, we go, okay, it ran, and as part of it running, it's saying that numeric values have been converted to character values at the places given by 90, so line 90, somewhere around column 22. So, this makes a lot of sense, because the variable n is a number. The macro variable is a string. We talked about that before. Macro variables are string. So the numeric value has been converted to a character value. The numeric value of n has been converted to a character macro variable. Okay, that's good. So SAS took care of that for me. So now I can run this %put statement, and when I say ampersand N55 observations have blah blah, it substitutes for ampersand N55 and we get the 9. So there we were able to get the value from a data step into a macro variable. Now there are probably easier ways to accomplish this, so we're not really showing something that you would normally do, but just trying to show you the principle of how you would do this. Now what we're going to do is we're going to do the opposite process. We're going to use simget. And in this example, we're going to use simget to grab the value of a macro variable. In this case, we're going to just go and grab that macro variable that we previously created, and we're going to make that a new variable in our data set here. So when we run this step, I'm going to go ahead and run this. Now I'm going to scroll up here a little bit. So it's going to grab the value of N55, which we remember is 9. It's going to add 0 to it. By adding 0 to it, we're converting this character value to a numeric value. So a string value of 9 plus 0, it's going to go, okay, I've got to convert that string value to a number. Adding 0 doesn't really change it. And then we get this message telling us that character values have been converted to numeric. And then this new variable, W55, will be a numeric value. And when we do this proc print here, we see that, hey, all of the observations have got 9. So we were able to get that macro variable back into a data file. So that's a little bit of tricky stuff, but that's how you can get macros in and out. That's kind of the interface between macros and regular SAS data files. Okay, so let's kind of recap what we've done here so far. So I'm going to bring up the web page here, and I'm going to scroll down. And so far, we've seen how we can access macro variables using ampersand. We've seen how we can use these macro functions to manipulate, do manipulations within macros. And then we've seen how we can use simget and simput to move data in and out of macros. So now let's look at another way that we can create macro variables, and that's using ProcSQL. And if you're not familiar with ProcSQL, perhaps this isn't the best way for you to do this. However, if you're a little bit familiar with ProcSQL, this is a pretty nifty way for making macro variables based on SQL queries on your SAS data file. So in this example here, this is very much like what we were doing previously. We do ProcSQL, and we're saying we want to select the sum of the instances where right is greater than or equal to 55. Well, this is just a logical statement which is true or false, and every time it's true, it's 1. So we're going to sum up how many times this occurs, and then we're going to put it into colon W55. This is a way in SAS of saying whatever this result is, put it in a macro variable called W55. We're pulling this from the data file HSB2. We do a quit, and then here we put out the value, and we see when we run this, it says W55 is 9. Well, that's what we saw before. And then here's another example. I think this starts really to show the power of using ProcSQL. The example is very similar to the one before, except here we're saying select the mean of right, and we're going into right 1 dash right 3. So actually what we're saying is right 1, right 2, right 3. The dash is telling SAS we want consecutive values. We're still pulling this from HSB2, but why are we creating 3 values? Because we're grouping this by SES, and we know in advance that SES has 3 levels. So right 1 is going to be the mean writing score for the first group of SES. Right 2 is going to be for the second group of SES, and right 3 will be for the third group of SES. And then below here we use a %put statement to show those 3 values, and indeed when we ran it in the log file we see right 1 to right 3 are, and those are the 3 means. So that's some pretty powerful stuff. So here in this section we saw how we could use ProcSQL and using select into for creating macro variables.